hexactinellid
Let video
sponge,
know.
so a glass sponge rather than a demo sponge, but I am not a hexactinellid sponge expert at all. So I'm not exactly sure what this is. So what we're looking at here, all those big openings are the X-current pores, or the oscules. So water sponges filter water through their bodies, and they filter out food particles.
Yeah, it's just
and so what we can't see are little tiny pores on the surface of the sponge into which the water comes in, and then goes through the sponge, and there's special cells that capture particles. And I think you've already explained this, maybe probably each day. And then the water is expelled through these larger openings, or the oscules. And you can see, if you look into those oscules, lots of smaller channels or canals that are feeding into it. So it's a pretty cool little system. And sponges filter a lot of water, so even more than we thought. So sponges are capable of filtering lots and lots of water. That's great. The zoom on that is really good. Thank you.
You're welcome.
When you zoom out on that, just to the lower left, it looked like there was a smaller, kind of bluish-green sponge as well, so much smaller.
I'll kind of track over there, see if we can find it.
The encrusting-looking sponge?
Just there, over to the left.
We saw one that looked fairly similar earlier on the dive.
Yeah. It really is a very sponge-rich area. So these are, again, here you can see maybe even a little bit better some of the in-current and X-current pores. But just in this image, in this screen, I'm seeing probably 4 or 5 different species of sponges.
Wow, that's very high diversity, isn't it?
Yeah, just in this one small area. Because then also in the upper left, we're seeing some like that roundish sponge. Again, probably a hexactinellid or a glass sponge. And you can see like it looks almost like a little straw, say at about 9 o'clock on this image, kind of to the center, but just to the left of the bluish sponge, it looks like there's a little tiny tube that we can Yeah. And that's probably a demo sponge. We saw some of these when we did the work in the Pacific as well.
Can you push that close contactor button?
Wow, that's interesting.
And then there's keep pushing the power controller to get the green back.
Maybe this bluish type 1 might be conolasma. Does that work for you?
I hate to put names on these things, and we just did a study on a mesophotic area in the southwest Florida shelf. And looked at all these things that we called red
we
crust.
accidentally hit the relay,
just calling
pushing
for
other
different
buttons.
things, and it turns out there are about 10 different species. So I really hate to even put a name on it. I don't even want to put a name on this.
All right, video. I think we've had a while here. Let's see if there's some other sponges.
It's a hexactinellid. It could be a demo sponge.
Sounds like we have a lot more to learn about sponges.
Yeah, a lot more to learn. And there's a major effort that's underway. Oh, and look at that thing over to the right. Okay, at about 4 o'clock.
Oh, yeah.
With the bubbly looking one, or the one with the
oh my gosh, I'm just looking at this whole area. There's like lots of different
may want to also
very, very rich area.
Increase your
this
altitude,
is awesome.
Now you're
so which is the one that you were excited about over this direction?
Just below the laser dots right
it's really
now.
easy to get in trouble before you know it.
Now
Sirius is sliding backwards up the hill.
Go back a little bit.
The fuzzy looking one?
Yeah, go back down and over to the left. Coming up.
On the left side of the 7 tap, just on the edge.
There you go.
This fuzzy guy, yeah.
Okay, very cool. Okay, so that looks to me like that's a demo, looks very much like a demo sponge. Oh, very cool. So this is one that is probably a sponge called Geodia. It's called Geodia because I don't know if you the geodes are, so the geologists do. But if you open up this sponge, it has a very thick cortex of very dense, delicious spicules, and then a different kind of consistency interior, so it looks like a geode. And all those projections are spicules onto which kind of sediment has accumulated. So these geodias are fairly common sponges in the deep sea. And then just up to the left of that is a little white sponge like that, or a glass. And in fact, what we might be seeing here with this geodia are actually two individuals, because it looks like there's a little one just underneath it as well.
Okay.
Great. That's here.
Before you leave, when you pull out, you'll see on the right side of the sediment patch that's ringed by the rocks, there's something pink that might be a sea pen.
Yeah, I was noticing that. Shirley, which...
Megan wants. I see a couple of these rhizome sticks.
Yeah, that's interesting.
Yeah, there is bottom left right now is a rhizome stick.
Bottom left. Shirley, are there any of these sponges that you would like to take a sample of?
I think that if we were going to collect anything, it would probably be the geodia, only because that's one that we've targeted to think about, like, population genetics work that we're doing. Although this is not, it's not really the species that the one we're looking for is one that looks like it's got kind of like pimples or bumps on the surface.
All right, come back in.
So I would say at this point, no. Let's just, I think we'll be able to identify that one.
Okay. We have a sea pen here. If there's any other requests for sponges, it looks like Andrea Quattrini was thinking about making a collection. Andrea, can you let us know which one it was, which species that you were eyeing?
All right, video, let's come out so we can figure out what they're looking for.
So this is an interesting view of a sea pen from the back side, or what they call the dorsal side in the sea pen, the Pennatulaceae world. And it's an octocoral, and you see that bright white line is the single internal skeletal rod, and around that is the fleshy polyp, and you can see it's anchored in the mud. And I'm delayed, so I'm going to stop because you might be moving to something else.
Andrea asked if one of these sponges is a Cophobelemnon. Sorry, I murdered that pronunciation, but does that ring a bell, Shirley, or anybody?
6543. I will let you know that that is going to delay us a little bit on recovery.
Up on the top of the rock there.
Let me rephrase. We're going to lose a little bit of extra time there because we'll need an extra chunk of time after the 300-meter transect
we're gonna go around
get the
so
ship in position.
Disc, maybe.
So typically we can kind of get oriented as the vehicles are coming up, but if we can't do that until 300 meters, the vehicles hit 50 meters a lot sooner than the ship is set up. So they'll be, for references, I did 15, starting at 1500 and then every 300 up to 300.
So we're making a little fly around the other side of this rock before we move on.
There'll be some lost time just sitting in the water.
It looks like there might be an ophiuroid on a sponge, maybe.
No.
The pink organism in the center of the screen.
Claimants. With the weather today, maybe 30. Because the ship will have to get underway, start getting its half a knot forward, into the wave wind, all that stuff.
Yeah, you can zoom video.
That looks more like a persingid than a ophiuroid.
But it is an ophiuroid. It is a burl.
Okay. Yeah, sorry.
Current is whipping.
Yeah, it's moving pretty quick.
Okay, video. Thanks.
One last thing. 10 minutes for each transect.
Just like stuff blowing off the vehicle. Let's kill those front lights. It's going to make it worse.
Lights are coming off, video.
Thanks.
Lights are off.
If anybody lost their
I'm gonna go
video
push out this
stream
other
for a little bit,
rock crappie over here.
We had a little glitch, but now they should be back up.
You pushing forward again there, pilot?
Yeah, just pushing out to this other rock outcrop over here. Just give a scan, make sure there's nothing we want to see.
Looks like there's something larger in the background there. And another larger sponge.
Come in partial video. Great.
It would be good if we could get a closer look at that. Yeah. Mm.
Wow, that's really interesting.
We can zoom in closer to this better lit spot here.
Shirley, any ideas about why sponges have such different shapes?
Oh, gosh. They've had over 600 million years to evolve, and there are close to 9,000 different species. And
wow.
They've been, they're adapted to lots of different habitats and environments. A lot of times when we see these fan-shaped sponges,
Great.
They're oriented so that, kind of into the current to maximize their ability to filter out food particles. This one's beautiful. It's really, really pretty sponge. Again, I honestly can't say whether this is a demo sponge or a hexactinellid. It looks more hexactinellid to me than a demo sponge, but I'm just not sure. A lot of the ones that we saw yesterday, I think, were these sponges called Fakelia, kind of a fan-shaped sponge with a very obvious base or peduncle or stem or stalk, and then veins running through, what look like veins running through, and those are just groups of spicules or these microscopic siliceous skeletal elements that provide structure. This looks really flimsy, like it's kind of like moving back and forth in the current that might be caused by the thrusters on the ROV. It's a big sponge, but in terms of like different shapes and sizes, and no, I mean this is a very diverse phylum with lots and lots of different body types, feeding strategies even.
Oh, that's so interesting. Thank you, Shirley.
So, Shirley, I understood you couldn't hear me well before. Hopefully you can hear me better now. I was suggesting that the close-up on that sponge, it reminded me a lot of the one that we were seeing in the Pacific that had the anemones growing as associates on it.
Yeah, that's true, Scott. I agree with you. And then I noticed also on that one that it looked like there were like kind of little star-shaped patterns in there, and I'm not sure what that was. Now this is, oh gosh, there's a couple things there, a few things there. What is that kind of grayish encrusting? Oh God, at least three different species, four different species of sponge in this, just in this image.
Wow, that's amazing.
I don't think I've ever seen anything like that brown one with white spots.
Yeah, me neither.
That's a beautiful squat lobster too.
Oh yeah.
So squat lobsters are another group that are quite diverse in the deep sea. Micalia? Ren Salgado was asking if this could be Micalia.
The which one? The yellow one or
the yellow one, I believe.
Okay, let's come out.
I think the yellow one is a hexagonal.
Bounce around. We got a good look of it.
Kind of grayish with the white.
Come on out, please.
I really don't know I think it's a demo sponge. It would be exceedingly difficult to collect. Any kind of encrusting sponges are really hard to collect.
Yeah.
Unless the rock is loose.
With a manipulator on.
There's also one in the center of the screen right now. It's smaller and it looks kind of green. Lime green.
Oh, yeah, there's a whole bunch of them down here.
I don't remember seeing that color very often.
Are we interested in getting a sample here?
Is it more of a branching one?
This one is, the lime green sponge is globular, circular, and it's behind the larger white sponge.
Oh, I see, way back there.
Yeah, straight up from the,
okay.
the left.
I see what you're talking about.
Are we thinking we might want to get a sample here? We could also get a rock sample.
Come on in,
as an
video.
Associate.
Yeah, there's also the round ones that look more like that geodia that you were describing earlier, Shirley.
Yeah, that one's over to the right. This, wow, kind of liking this white one.
Yeah, there's one on the left of the green.
How many samples have you already collected today?
Only one, I believe.
We just have one biosample.
We have plenty of room if there's anything that you would like to have a sample of.
You have your buffet in front of you, which
I see that.
It might be overwhelming though. There's too many choices.
I'll say the same thing that I used to say when we were out there. It's like, can we just poke it and see what it is? But I know that was just a running joke, but we can't.
No, we used to do that with shallow water sponges
we
too.
We can poke the rock and see if it's loose, and that way we're not damaging the sponge.
Yeah.
What would be your favorite target in this vicinity?
My favorite target here would be that big white one.
Okay.
That would be nice. Because I don't know what that is.
That rock won't fit, unfortunately.
It could be a hexagonella, but I don't think so. I think it's more of a demo sponge. I mean, yeah, this is incredible. I'm seeing a geodia over. There are two geodias over to the kind of the 10 o'clock position. But I'd say if I had my choice, it would be that big white one right in the middle.
Go ahead. Yeah, maybe. Let me just see if I can get properly settled.
And I'm afraid I can't give the pilots any advice about whether they're on the consistency of this, whether it's going to be mushy or fragile or rubbery. I just don't know.
Well, that's going to certainly play a role in whether we can collect it or not, but I'm willing to take a look.
Too bad we can't just take that whole rock. That's exactly what I need.
Yeah. Need claws on the bottom
that
of the vehicle.
That would be really cool.
That would be. I think it's a little too big. Huh?
Yes. Much too large. Yeah, go ahead. Watch lead. Yes. Yeah, that is. If we had like claws on the bottom, we could like just create a little rock baby, then maybe. But unfortunately, it's much too big for any of the rock boxes that we have.
And I doubt it's even loose.
Yeah.
Pilot, you're ramped up.
Sadly, the pilot has verified it's too large a rock, which, one can always hope.
Shirley, while they're setting up to collect the sponge, would you be able to tell us a little bit about the potential pharmaceuticals that are found in sponges?
Sure. So we've been doing work for
would you like to aim for starboard
more than
bio
30
box
years,
this time?
35 years, and other
or we
groups
have one sample on the port, or do you want to go to the port outer?
We can go port outer.
Early 80s, looking at
depending on what it takes to get this. If I get a good chunk of it,
by
then
marine plants and animals that can
I got a good grip, then we can go port.
Primarily
but
to treat cancer, but now expanding that to look at antibiotics, things to treat neurodegenerative diseases like Alzheimer's, and what we found some really interesting chemistry from sponges that live in
can you just give us a partial zoom real quick?
Again,
just want to learn a bit about the texture of this sponge
sponges, almost
before we go
9,000
grabbing it,
species
just
of
to know
sponges.
what to expect.
You can expect that they're going to produce different chemistry.
So it is squishy.
And the chemistry is really related, I think, to what they. They're not going to produce chemicals that they don't need. We call them secondary metabolites. They're not needed for primary functioning, but help them in some other way to survive.
I don't know. Probably not.
Oh, looks cool. Looks very good.
It's very squishy.
And
I don't think it'll peel off. I think I'll just tear it up.
It's not so far-fetched to think about why sponges don't get cancer. In the decades of work that I've done on sponges, I've never found a sponge that has tumors in it. And but I don't think that they produce these chemicals as cancer-fighting compounds for themselves. I think they produce these chemicals. These are chemicals that are produced to prevent cells from dividing. And when you think about it, these sponges are living on the bottom. They can't get away from predators. They can't get away from things that are trying to grow over top of them. And so what they do is they have a chemical arsenal that they use to protect themselves. So you can think about why would they produce chemicals that prevent cells from dividing? And that might be because if there's something that's trying to grow over top of them, they'll release that chemical, and it will prevent the cells of, say, another sponge or a coral or something like that trying to grow over top of them from the cells from dividing. Sometimes they produce anti-inflammatory compounds, chemicals that will prevent them from having some kind of a inflammatory response to something that's trying to grow over top of them, or to prevent things from fouling, from settling on it. So when you think about antibiotics, again, these are filter feeders. They're trying to protect themselves, make sure that there are not any disease-producing or pathogenic bacteria from growing in them. So there are some ecological reasons that would underpin why we're successful at finding chemicals that also have human health applications. So this sponge that we're collecting right now is pretty squishy. I still think it's a demo sponge. And just for people who are watching this and are concerned about it being kind of all cut up like that, Sponges are amazingly plastic. So, for example, all these pieces of this sponge that are left on the bottom, we're not going to be able to collect all of it. And the sponges can heal themselves pretty well, and they can regrow. And so, these sponges, that cut surface will be able to heal itself probably in a couple of days. And, it's enough for it to be able to regrow. And for us back on shore who want to identify what this sponge is, we can take pieces of this and look at what kind of skeleton it has, how the mineral skeleton is arranged. Take a look at the molecular signature of it, and be able to place and identify what it is. So, thanks for that collection. That was great. I think for people watching, you should know that it's really difficult to collect these sponges that are squishy, sometimes brittle, very fragile, and this is still a very, very valuable collection for us. So thanks.
Shirley, for the molecular work, what is the best preservative of DNA for sponges? What you're doing out there is you're putting them in, I think, 95% ethanol, so that'll be fine. And I think, are you still doing the OGL samples? Yes, we are.
Retracting.
Okay, so that'll be fine. So the way you're already preserving them is will be just fine.
Great, thank you.
And that also helps us then having them in the ethanol too. That we can go ahead and then make kind of what we call histological sections. So section through, look at them under the microscope, and see how these little microscopic elements called spicules, skeletal elements called spicules, are arranged in fibers in the sponge. So we'll be able to identify the sponge. So it's a very exciting collection. And I understand from Nolan, who's been participating in the dive, that you've seen this in a few other places during the dive. So I feel pretty good about collecting.
We can stand by.
Great.
We can nudge around. Nudge around. See
we can nudge around. See if is there one in view that you'd like to go for?
Leave it up for now.
Coming back up.
It looks like a holothurian is coming past. Sea cucumber. It's the reddish organism that's in the water column just above the rock.
Roger that. Hey.
So the squat lobster rock?
Yeah.
Give that a try. Okay.
We're going to nudge this rock that has the squat lobster and see if we can loosen it to get a rock sample here, and maybe also get some associates, or I don't know if the squat lobster needs to come, but maybe another sponge would be attached. I doubt the squat lobster will agree. He should go with
that rock is not loose.
It is not, okay.
Unfortunately. Right. I don't think this one is either, but we can poke it. That doesn't look like the right kind of stuff, though. We can zoom a little. Hold on. Let me get the arm in a little safer position. Turn my face a little bit. See if I can get myself
Squat
turned.
lobster's getting nervous.
As he should.
Understandably.
And while they're setting up for this rock collection, just an update on our bottom time.
It's the one with the stuff on top, the white and brown on top.
A little bit earlier than we thought, so that the ship can set up for recovery after the midwater transects.
The other rock, the rock that's loose, we can't even see the rock. It's that stuff with the brown and white encrusting on it. I'm not sure that it would be useful for a geology collection. Okay.
So co-pilot.
What is going on? It was indexed out. I didn't touch the button. I went to set it here.
Yeah.
I don't know what's going on with that.
And anybody who wants to join in the dive planning call for tomorrow's dive, we'll have that at 18:35 UTC, which is about 2:35 Eastern Daylight Time.
I had it hanging out here, indexed out, like put it down, drove all that stuff, or like
there'll also be a water column.
Drove all that, and then was like going to set it down for a second to do something.
Which is 1840 Eastern Daylight. And then for those wanting to watch the midwater transects, those should start.
What I was going to say to you is, even if you don't pull up mini zoos on the screen during sampling, it's probably still a good idea to try to take control and point it at a bio box so he has that view from above.
Okay. And how do I do that?
So you'd ask to take control of mini zoos from pilot.
So
that would be your top left. You have to push it in till it's red. Yep. Red means D2, and then you'll have control of the mini zoos. So go ahead and give it a try if pilot's okay.
Yeah, go ahead. You can name it down between the toes where it belongs.
I don't think so. This looks different than anything we've seen on this dive so far. It's
and
like another sponge
what am I driving it with? The upper left joystick?
Yeah.
Yeah, this is definitely different.
It's not responding.
This is more like one of those Peculiar sponges.
Gotcha.
And it looks to me to be different from what we saw yesterday also.
So you think it's similar to what we were seeing yesterday?
Similar, but I'm not sure
generally
it's
that
the
point's
same.
right between the toes.
Okay.
Or just at like the edge of the toes. But as he's sampling, it would be helpful to bring it over and kind of get that view. So for now, you can pan right again and tilt up a little.
So this is what I was talking about, where you could see that like that peduncle or stalk. So a narrow base of attachment to the rock, and then this big fan shape, and then
a few more degrees even, just kind of get the edge of the toes in.
Veins or tracks of these silica spicules that form, they look vein-like, but have to be switched to keep the structure.
And then to do the camera
really
in the monitor to the right,
I think this is a Peculiar.
You would reach over to the other joy box.
Is there any view you want to close up on to determine that?
ID1, so you would click 1.
Is there any close-up view you'd like, Shirley, or anybody?
Left.
This is an island.
Oh,
looks great.
And then you should have control of it.
Gotcha.
Island in the screen.
Give me a partial right here while they
camera,
think about
to
that.
enter.
This is an interesting little.
There's some more of those stalk organisms that we saw earlier.
Watch leads nav.
Yeah.
Watch lead.
Wanted to let you know we've received our transect depths.
Okay.
And based on our new calculations, our off bottom is 18:30 UTC, so an hour and 20 minutes from now.
18:30. Okay.
So
the top.
This might be a predatory tunicate that we're looking at here.
Go ahead.
The top of the hill here is
there
220 meters away.
Did you want a closer look at that other sponge still?
That's going to be about 36 minutes.
Excellent. Thanks for the update. Thank you.
I think the sponge that's smaller of the sand sponges is very similar, related to that really big one that we saw a little while ago. Mm-hmm. Whereas this one, the one on the left is a completely different species and maybe even a different class.
Wow.
Yeah. So this is a demo sponge that we're looking at right now. It's probably the genus Phacelia. And the one in back of it may be a hexagonal sponge. Again, you can see that core surface. Oh, and you can see the little brittle star there. Yeah. I'm moving around my screen with my cursor like you can see what I'm actually doing here.
It's a beautiful shot.
Yeah, very nice. Very nice. It's unusual to see kind of the way the fan is almost like at the fringes, almost like fingers or branches. That's kind of an unusual way to see these sponges. Usually it's just a very smooth edge, smooth border. So to have it kind of like fringed like that is very interesting.
Great.
So we've been informed from NAV that we have about an hour and 15 minutes remaining, and we still have some distance to cover if we need to feel that we have to go to the end of the track. It would take 36 minutes to get to the end of our proposed dive. So we're going to keep heading in that direction, but again, as we said before, if anyone sees anything they want us to stop for,
sounds good.
Especially a collection,
great,
or to zoom in on something we haven't seen, please let us know. This looks like a nice little community over here. Seeing a little more of the edges of the rocks being inhabited by this rows of sponges. This is very interesting. So at this point we're facing northwest. So not quite. Yeah, northwest. I'm still keeping my eyes open for a rock sample that would have a couple sponges on it as bonus. Do we want to look at these sponges in front of us? Or the one that's center screen middle? I mean, just up above the middle?
I think let's just go ahead and let's continue on the track.
Okay.
Yeah.
This yellowish sponge that's now in the center of the screen, is that of interest?
We can take a quick look at that.
Okay.
Yeah, you can snap in.
So that looks like one that we saw yesterday. So Scott, that's that geodia in front of us that we were looking at. So that's the geodia, and that the one that looks like it's got kind of like pimples on the surface, so right in the center. So not the yellow sponge.
One that's facing us.
Yeah, so that's facing us, right?
Yeah,
that's
one
that we're interested in. It occurs to do some population genetics work.
So surely I see this very flat plate sort of facing us, and then there's that sort of grapefruit-sized ball sticking out to the right. Is that both the same sponge?
Not sure, but if I had to select one, it would be the one on the left-hand side, the one that's got the flat top.
All right, thanks. Right. Well, we've only got an hour left. If you want to collect this, I'm fine with that.
Yeah, let's do that. I think it would be worthwhile to do that because then we could have something from this area. That would be really good.
Go ahead.
This one should be relatively easy to collect, famous last words. It'll be fairly rigid.
We like rigid.
The others might come up with it, just as a sort of one. This sponge is Geodia, and it's probably Geodia pachydermata. So think about pachyderm.
Yep, thick skin.
It's got a very
you are ramped up,
skin.
And we'll be going to the starboard
the Geodias, as I mentioned before, have a very thick kind of cortex with densely packed, delicious spicules that look like little stars, and forms a really, really dense cortex. So again, and when you're sampling, when you're preserving this, Cheryl and Leslie, because wear gloves, and just be mindful of the spicules, because in addition to those little star-shaped spicules that are on the surface, inside are very long, pointy ones that will go right through your glove, so double glove.
Thanks for the warning, Shirley. We will certainly glove up well for processing the sample.
And I'll let the biologists do that.
Your rocks don't have spicules, do they?
Well, they often do. They do have spicules that the sponges leave behind.
Oh, that's true.
Yeah.
So we're kind of interested in this. By we, I mean the sponge community. This is a sponge that is, the species occurs throughout the Atlantic, and very little has been done on like how related the different populations of these sponges are. So we're interested in looking at how connected these populations are. We're going to hopefully be able to do some molecular work on this as well.
Do you want the front lights on? Would that help?
So Shirley, we collected
Yeah, go ahead.
No, I think it's okay.
We collected one of this genus, I think, yesterday, and it was significantly more shallow than we are now. Would you expect that the species that we collected yesterday is different than this one?
No, it could be the same. We've collected these in much shallower waters with the Johnson seedling.
Oh, wow, okay.
In fact, a lot of the work that's been done on them was from sponges that we collected in the Johnson seedling, which went no deeper than about 1,000 meters.
Okay. Generally, with a lot of invertebrates in the deep sea, there's the same species don't occur above 1,200 meters as below, so there's a change out in species. Some of the same genera or types of organisms will be in both places, but they're usually different species.
And what's also interesting is that some of these, we haven't seen it so much in the deep water organisms, but in shallower water, we get different chemistry at different depths as well.
Right.
Okay. Ready for draw extend?
Yep.
Draw's coming out.
And again, for those of you watching, don't be disturbed about that sponge that's toppled over on its side. As I mentioned, the cells are it's very plastic. That sponge will reattach.
Draw is out.
Great collection.
Shirley, is there interest in the yellow one that we knocked over? You said it would probably still grow, but is there interest in collecting it to make sure we know what species that is as a representative of this area?
Yeah, I think especially since we saw that yesterday and we weren't quite sure what it was, whether we were looking at actually two different species or one. It could be one thing over another. So yes, that would be for that time to pick it up.
Would you like that to go in the same box as the original one, or the one we just picked up?
Is it okay to put it in the same box as the one that we just picked up?
Yes, it is.
You can close the drawer for now.
Okay.
That's an affirmative, pilot.
That took 4 presses for it to disable. I guess so.
Drawer is closed.
Thanks.
Do you want me to take Mini Zeus and try and get a better view of that box, or are you comfortable?
Yeah, you can bring the Mini Zeus down if you want.
Do you know how?
Control Mini Zeus.
So sometimes there are sponges that encrust on other sponges. And yesterday there was some discussion about whether this is a single species or two species, and there's and I really don't know the answer to that. So, but for sure we'll be able to determine that once we get this sample. And so sometimes there's a very thinly encrusting yellow sponge.
Did you see that?
I can't remember right now.
So I hit it,
but it's
the arm moved a little and then stopped. So it indexed in and then itself back out.
Other sponges
with one press.
Especially in deeper water.
It went like
so
this.
We really commonly saw this when we did a lot of our collections.
It's like it's
the Johnson
taking a double press or something.
Doing some work for the biomedical research program. So,
notice how you've lost view in main series?
Species or
so, a lot of things to balance during
and you don't
samples.
need to do anything special for the you don't need to dissect these at all. Just go ahead and preserve it whole, and then we'll worry about looking at the exosome or the outside surface and seeing if it's actually the outside surface of one sponge or if it's another sponge encrusting one.
Can we put the mini Zeus up here for a little while once you get yourself situated, and then take a partial zoom? I'll do it. Yeah, here. Right, ROV HD2. And then can we zoom in a little? Thanks, video. And then just nudge it left so I can see a little better. The other way.
Other left.
Just on the sponge there. Yellow sponge. Thanks. That doesn't really help, does it? Okay.
It's been interesting for me to compare yesterday's dive and today's dive. Different depths, of course, but both had rocky outcrops on this sediment plain. The difference being who lived on the rocks. And yesterday we had a lot of sponges, but we also saw a lot of the corals. And today we've seen many more sponges and almost no corals. Was that anticipated? I believe it was, but I just want to make sure that that's sort of what was expected at these depths. Can you talk about that, Shirley?
Yeah, I can't explain why we're seeing these differences in different populations, different abundances, different areas. Yeah, I don't know. I can't really address that.
You ready for the drawer to extend?
It's okay to say I don't know, right?
Yeah.
Coming out.
Stand by 1 second. Just putting this in the box. I'll be right with you.
Fully extended.
That helped you out. Chunk fell right in.
And it looks like in that collection we got at least 2 brittle stars, 2 different varieties of sponges.
Okay. Ready for the drawer to retract?
Yeah.
Drawer's coming back in. Drawer's all the way in.
Okay, watch lead, I'm with you. Sorry about that. Watch lead pilot.
Wrapping down.
Hold off on moving for 1 second.
Disabling HV.
Just drop one. Thank you. Perfect. Watch leads pilot. You called me a second ago. Oh, no problem. All right, take this back. Center it up for you. Yes. And we're continuing on. Yeah, Bobby? You good? Okay. Awesome.
Okay, I'm looking down at you at 66 degrees right now.
Perfect.
Watch leads nav so that we are all on the same page. That is marked as Spec 03 Bio.
And I'm coming around, heading towards waypoint 2.
Perfect.
So it will be towards your port.
03 and 04, you got it.
Coming up to get you in view.
Beautiful. Thank you, Lars.
Go ahead. I believe you're asking about the 100 meter.
Got you there at a 45. I am lined up with the target.
Roger.
Great.
Stand by one.
When you're done with your labels and calculations.
You want to move?
Yeah.
You got it.
Thanks.
We're continuing along our transect. We have about an hour left in the dive. We've now made 4 bio collections.
Nice collections, pilot.
Some sponges and
Do you think the bio boxes will be cleaner now that we got sponges in there?
Watch leads nav.
Certainly.
Waypoint 2 is 170 meters away. Bridge, ROV nav.
So as we continue along,
Yes, can we repeat the last move, please?
5 meters from waypoint 2, the end of our transect. We're now at 3,365 meters.
Good copy, Bridge. Thank you.
You have to get in eventually. There's only an hour left.
You're getting a little tight on your tether there.
Thanks.
Thank you, Bridge.
Hiding in plain sight.
if you're just tuning in, we've covered some distance today. What, 300 meters, 400 meters? Close to 400 meters. And we've stopped numerous times to look at rocks that we find scattered across this sediment plain. Several different collections we've made.
Got you there at 30.
We've had some great assistance from our chat room folks. Scott France and Shirley Pomponi have guided us on many of the identifications of these sponges. And we have, how many people are also on the chat line? 32 other people are checking in with us, listening along, and contributing through the chat room to help us make some of these identifications, and also to help us select what's necessary to
I haven't
sample.
seen this yet today.
We very much appreciate their contributions.
You have a little bit of room to go forward if you want.
Yeah, and going back to what I was
Not
talking
lot,
about earlier, the submersibles versus the ROV.
I can also come down a little bit lower if you want to have a little
this
bit
is
more.
A huge pro of working with an ROV is having all of these experts in different fields of biology and geology that can
anybody's
tune
gonna
in
find a
and
rock,
tell us
it's
what
you.
we're seeing, help us interpret what we're seeing and know what is new or possibly new versus what is more common for that type of organism.
Current's going down, maybe last half hour.
Now let's take a look at this. Looks like a Brisingid sea star, perhaps?
I guess so.
No, those are 3 good bios.
Yeah, the samples are in the box.
4 good bios.
Hopefully the vehicle's in one piece.
4 good bios, that first one especially.
We seen one of these yet today?
Yeah, I think we have seen one of these Brisingid starfishes today.
Okay.
Maybe not in this position, though, with the arms curled upward.
You want a quick look? We're stretched out.
Yeah,
sure, if we can take
sure, that'd be great.
Yeah, go ahead, video.
They're very photogenic.
I'll say.
We learned from Scott France yesterday that this is an unusual sea star in that it does curl its arms upward into the current, and the tube feet that you see sticking outward help to trap particles that are flowing by in the current. So it acts more as a filter feeder in this case instead of a roaming predator. Its mouth is on the underside. It's a little lighter in color than some of the ones we've seen.
Any part in particular you want to see, video or science?
Can we zoom into a tube foot maybe?
Yeah, sure we can. Come on a little tighter.
We keep talking about these. Of course, we're not really seeing them in action.
Yeah, they're just kind of clinging, huh?
They use a water vascular system pumping through the arms that controls the movement of these appendages that are called tube feet. And on the tip of their arms is an eye stalk that is a sensory organ that helps them find their way, I gather.
Yep. We're happy when you are, video. Make sure we hit it with the lasers. I'm not sure they're on. Right now they are.
That's a nice shot. He's pretty small. End to end, probably 15 centimeters if he had his arms down, maybe close to 20. But
I thought he was a lot bigger than that.
I did too. We always do.
I guess when you're zoomed in.
Yep, yep. The zoom is so good and the clarity is so good. Both Cheryl and I have been in submersible dives west of here in shallower waters, and we've gone back and looked at those video, and
thank you, Bridge.
It's quite a different
complete
quality of video compared to what we're seeing here.
So Nolan Barrett just added into the chat room that this might be a Frelaid group of the Brisingidae, and he thinks that because of the depth and as well as the slight bulge at the base of each arm ray.
Nolan's on his Sea Star stuff lately.
Was joking that we need to turn on our Sea Star signal so that Chris Ma might be able to join us and verify. Yeah, he's some scientist that calls in very quickly whenever there's a new sea star in sight. But we hear that he's in Japan now at a meeting, so he can't be joining us like he has in the past, at least this week.
Hopefully he'll be able to tune in on a future dive. As we get into the shallower waters, I think we'll probably see a lot more sea stars.
Want another? Bridge.